Okay then, our last bit of chapter 4, demand and supply analysis. Now in our last class, we were taking a look at this idea of market equilibrium, right? Remember the question we're trying to ask, or rather answer, is what determines price in competitive markets, correct? If the price of oil today is, say, $45 a barrel, why is it $45 a barrel? Okay? And the answer very simply is that $45 a barrel comes from the interaction of market demand for oil and the market supply of oil, as in this diagram. Okay? So very quickly, to recap briefly, we have here a diagram in which we draw the market demand curve and the market supply curve in the same diagram. And we start with a price of $1.50 a bottle of water, right? Now at that price, you can read off from the market demand curve the quantity demanded of water, which is 9 million bottles per day, correct? You following me here? And at that price of $1.50 a bottle, the quantity supplied of water, on the other hand, is 11 million bottles per day. So we have surplus water here of 11 minus 9 equals 2 million bottles a day. And that is that horizontal gap here between these 2 points here. Is that correct? Now, what happens when there is a surplus of a good? Firms are stuck with unsold stocks of bottled water. Firms don't like this. So firms are going to engage in competition with each other. Each firm is going to try to steal the other's customers by lowering price. But of course, when one firm lowers price, all the other firms follow suit. And so the price of bottled water starts to fall, right? Now by tomorrow, the price of bottled water may fall to $1.25 a bottle. Now at that price of $1.25 a bottle, you will notice that there is still this horizontal gap between the two curves. So there is still a surplus. Now it's a smaller surplus than before, but there is still a surplus. And as long as there is a surplus, we have downward pressure on the market price, correct? And I'm going to write this down here. So when you have a surplus puts downward pressure on the price, right? So a surplus causes downward pressure on the price, and so the price falls even further. And when does this fall in the price stop? When the price reaches $1. Now, why does it stop falling after that? Because once the price reaches $1, you will notice that there is no longer a surplus. Because at that price of $1, there is no horizontal gap between the market demand and market supply curves, correct? So at that price of $1, the quantity demanded is 10 million per day, which is also the quantity supplied, right? And this quantity of 10 million bottles a day is called the equilibrium quantity, and we denote it by Q star. So Q star is the equilibrium quantity, right? And $1, which we call P star, is the equilibrium price, right? So what we've learned here is that when price is initially above its equilibrium value, there is downward pressure on the price. Why? Because there is going to be this surplus, right? And surpluses lead to downward pressure on the price as firms compete with each other for customers, right? And the price then drops, right? Now, if the price, on the other hand, was 50 cents a bottle to begin with, okay? So if the price of bottled water were 50 cents to begin with, what would our story be? Well, at that price of 50 cents, you can read off the market quantity demanded, correct? And you would use which curve to do this? The market demand curve, right? So you would go sideways from here like this till you strike the market demand curve, and then down like that, about 12, pardon me, about 12 million bottles a day. Right? That's the quantity demanded, read off the demand curve. What about the quantity supplied? Well, that you would have to read off the market supply curve, and if you go vertically down like this, you arrive at about 8 million bottles. So what do we have now? We have this horizontal gap between the two curves. What does this horizontal gap signify? A shortage now. Why? Because now quantity demanded is bigger than quantity supplied. Is that correct? So this is called a shortage. And how much of a shortage is this? This is a shortage of 4 million bottles a day. Right? Now, when there is a shortage of a good, what happens? Well, when there is a shortage, consumers start to compete with each other. Consumers start to compete with each other for the scarce good. Right? And how do you and I compete with each other? By offering the producer more money. Correct? So you and I then bid up the price of bottled water as we compete with each other. Correct? So a shortage then, a shortage puts upward pressure on price as consumers compete with each other. And so the price starts to rise. And by tomorrow, the price may, for instance, reach 75 cents. Now, at the price of 75 cents, would the market have arrived at equilibrium? No, because at a price of 75 cents, there still exists this horizontal distance between the two curves. In other words, you still have a shortage. It's a smaller shortage than before, but there is still a shortage. And this is going to continue to put upward pressure on the price. Correct? This will continue until price reaches $1. Once the price reaches $1, there is no longer any more upward pressure on the price because quantity demanded equals quantity supplied. Correct? Now, why do we use the term equilibrium? What does the term equilibrium mean? Equilibrium means position of rest. Right? So we call P star the equilibrium price, $1, the equilibrium price. Why? Because once the price reaches $1, it comes to rest. It doesn't move any further. Neither does it rise, or neither does it fall. Correct? So we call that the equilibrium price. And similarly, 10 million bottles per day is called the equilibrium quantity, because once the market quantity reaches 10 million bottles, it too comes to rest. Right? So now, when you look around you and you observe that the price of oil is $45 a barrel, what is that $45? Is it $1.50? Is it like the 50 cents, or is it like the $1? Well, chances are it is the $1 because markets come to equilibrium very quickly. So the prices that you observe around you are likely to be equilibrium prices, because if they weren't, they would very quickly move to their equilibrium values. Do you follow me? So the prices that you observe around you for commodities like wheat, soy, oil, etc., these are all likely their equilibrium values. Because if they weren't, as I said, they would very quickly become or come to their equilibrium values. Right? So this is how prices are determined in competitive markets. If I were to ask you, how are prices determined in competitive markets? You would say, by the interaction of market demand and market supply. What do you mean by interaction of? What you mean is basically where the two curves intersect. That's what's going to determine the equilibrium price and the equilibrium quantity. Clear? Now we are going to look at some perturbations. We're going to look at something that disturbs this setup. Okay? But before I do so, I'd like to make sure you understand something else here, and I'm going to now move to my drawing board. Okay, and let me quickly draw a diagram here for a market. By the way, this should come very easily to you. All you need to do is draw a large L and then put an X in the middle. Okay, so you should become adept at doing this, because you're going to have to do this a lot to figure out the effect of an event on the equilibrium price and equilibrium quantity. Quickly label this. Let's call this the quantity of bottled water. That's the price of water. This is the market demand curve. This is the market supply curve, correct? And in this market we have an equilibrium value of the market price, which is that, and the equilibrium quantity is that. So this here is P star, and this is Q star, okay? And now let's say that the weather warms up. Summer arrives in full force. What do you expect that to do to this diagram? Well, with the weather warming up, what would happen in this diagram? Would demand change? Would supply change? What would happen? Yes, because as people become more thirsty with the warmer weather, you expect the demand for water to rise. What do I mean by demand for water to rise? This is an increase in demand or quantity demand? Demand, exactly, because this is being brought about by, not by the price of water falling. No, people are drinking more water, not because it's cheaper, but because it's warmer. Correct? Because the weather is warmer. So this would be a rightward shift of the entire demand curve, correct? So let's show that here. So we have a rightward shift of the entire demand curve like this to curve D prime. Now, the moment this happens, what is going to happen in this market? What is the sequence of events? Well, firstly, you will notice that once the demand curve shifts to the right like that, at the old equilibrium price of P star, you will now have what? A horizontal gap between the supply and demand curves. Is that correct? Now, is that a shortage or a surplus? That is a shortage, am I correct? You see, because at that price, the quantity, the quantity demanded of bottled water, this shall be the quantity demanded, whereas this shall be the quantity supplied. And so you have quantity demanded exceeding quantity supplied. We have a shortage. So this here is a shortage. And we have learned that shortages put upward pressure on the market price, correct? Yes? So we shall see the following happening then. So we have an increase in demand. This leads right away to a shortage. The shortage leads to the price rising. Is that correct? And so the price shall rise to what? The price shall rise to its new equilibrium value, which is going to be that. That is determined by the intersection of the new demand curve D prime and the supply curve. So this should be the new equilibrium price P double star. So the price rises. Is there anything happening on the supply side, by the way? Would you say that an increase in demand causes an increase in supply? No, because you see an increase in supply is a shift of the supply curve. And you see here that the supply curve hasn't shifted. However, there is something happening on the supply side. What is happening is this. You have the original equilibrium. Here, let's call that point A. And point B is the new equilibrium. So what do you see happening along the supply curve? you have a movement along the supply curve like that. Correct? A movement from A to B. So in other words, when the price of the good rises, we have an increase in quantity supplied. Do you follow? When the price rises, you have an increase in the quantity supplied. So when demand rises, you have an increase in quantity supplied. So what we've learned here is that changes in demand lead to changes in quantity supplied. So this is a sequence of events then. Is that fully understood? Back to our PowerPoint. Let's look at some events here now. And you and I should work through this and figure out what's going on. Okay, the effect of the event on P star and Q star. Okay, so this is the event, and we are supposed to do what? We are supposed to find out the effects on P star and Q star. That's what we need to find out. So the event is, a new study says that tap water is unsafe. What's going to happen in the market for bottled water? Now, before you jump to your answer, which you may use, which may sort of intuitively come to you, I don't want you to do that. I want you to instead work through this by drawing the appropriate diagram: market demand, market supply, etc. Okay? So that's the kind of training that I wish to impart to you. You don't jump to the answer right away because common sense can sometimes be wrong. I'd rather you work through this formally. Okay? So firstly, bottled water and tap water. What's the relationship between tap water and bottled water? Is there a relationship between these two? They are substitutes, exactly. They are substitutes, correct? So if tap water is unsafe to drink, what do you think will happen in the market for bottled water? I'm going to draw a little diagram here. Quantity of bottled water, price of bottled water, market demand curve, market supply curve. What will happen in this diagram, do you think? This is the market for bottled water. Well, if people can't drink tap water, what are they going to do? Come on. They will? They will buy more bottled water, which means that the demand curve will shift to the, exactly. So the demand curve for bottled water will shift to the right like this to curve D prime. Yes? Now, what is going to happen to the equilibrium price of bottled water and the equilibrium market quantity of bottled water? This is the, yes, you've got it right. This is the old price P star. This, on the other hand, shall be the new price P double star. Correct? And what is the old equilibrium quantity? That would be Q star. And the new quantity shall be Q double star. So what we have happening here, basically the equilibrium price rises and the equilibrium quantity also rises. That's our prediction. Correct? What about quantity supplied? Is there anything happening to quantity supplied? Pardon me? Is there something happening to quantity supplied? No, of course something's happening to quantity supplied. Nothing's happening to supply. Nothing's happening to supply because the supply curve isn't shifting, but something is happening to quantity supply. Come on, tell me. There is an increase in quantity supplied, exactly, because you have a movement. You have a movement like this along the supply curve. You have a movement along the supply curve. You have, in other words, a shortage first, which drives up the price, and the higher price then increases quantity supplied. Is that understood by you then? Okay. All right. Here's another event. It says here, a new 0-calorie sports drink is invented. What's going to be the effect of this on the market for bottled water? Once again, we need to draw a diagram for the market for bottled water. What's going to happen now? 0-calorie sports drink, what is the relationship between this and bottled water? Substitutes again in consumption, correct? They are substitutes in consumption. So with the invention of this new 0-calorie sports drink, do you think some people may switch from water to drinking that instead? And so what would happen in this diagram? Aha, you said down. What do you mean down? Vertically down? Ah, yes, that's what I want. Left, not up and down, but left and right, correct? So the entire demand curve then shifts to the left, remember. It's a leftward shift of the demand curve. And so the entire demand curve shifts to the left like that. And what does that do to the equilibrium price and the equilibrium quantity? Well, it's easy to see here. The old price was that, and the new price shall be this. So the price falls. The old quantity was this, and the new quantity is that. So the equilibrium quantity falls as well. So we have P star falling, Q star falling. What about QS? Yes, that falls as well because you have a movement down the supply curve like that, and so quantity supplied falls as well. Yes? You're going to look at a few more events here, okay? We discussed this already. And now we're going to look at something that cause supply to change. It says here the event is that European water bottlers buy springs and open plants in the US. So this is the US market for bottled water. Now, when you have an increase in the number of sellers, when you have an increase in the number of sellers, which curve is affected? Demand or supply? Supply. Yes. You see, that was, if you remember, that was the very last, oh no, not the very last, but perhaps the next to last point on the slide that discussed factors causing shifts in the supply curve, correct? When you have an increase in the number of sellers, you're basically adding up more of these horizontal distances to arrive at the market supply curve from individual firm supply curves, correct? So when you have more individual firms' curves to add up, of course you end up with a market supply curve that is further to the right, correct? So the entire supply curve now shifts in which direction? Right. Exactly, shifts to the right. Once again, not up and down, but left and right. So we have an increase in supply like this. So this is our new supply curves, right? And what is going to happen to the equilibrium market price and the equilibrium quantity? Well, the old market price was P star given by this intersection there. The new equilibrium should be given by this intersection. So the new price shall be P double star there. The old quantity was Q star, and the new equilibrium quantity shall be Q double star. So what's happening to the equilibrium price and the equilibrium quantity? The equilibrium price is falling. The equilibrium quantity is rising. What about quantity demanded? Here we have an increase in supply. Question to you. Does an increase in supply cause an increase in demand? Or does it cause any change on the demand side? Well, you observe here that there is a movement along the demand curve in this direction. Is that correct? So what is the sequence of events here? You see, if you think about it, what happens when the supply curve shifts to the right like that? Well, here is what is going to happen. If the price remains P star, and you have a rightward shift in supply, right away a horizontal gap emerges between the two curves. This gap is what? A surplus or a shortage? Yes, that is a surplus. So this gap is a surplus. And we know what surpluses do to the price, correct? Surpluses put downward pressure on the price, correct? So the price starts to fall. So you have here supply going up. An increase in supply causes a surplus of the good. The surplus causes price to fall. And a fall in price does something on the demand side. What does it do? It raises what? Demand? No. Demand doesn't change because, yes, we need to use the right terminology. Quantity demanded rises. Is that correct? So this movement here from point A to point B, this movement along the demand curve is an increase in quantity demanded. Yes? Let's make sure we completely understand this stuff. Okay? Here's another event. The event now is drought dries up some springs in the US. Now remember, these water bottling companies get their water from these natural springs, okay, supposedly. These springs dry up. What's going to happen in the market for bottled water? Well, is that a supply side issue or a demand side issue? Supply, exactly. So the supply curve should shift to the left like this. And we can see there right away that there is going to be, by now you should realize what's happening now. The price shall rise. The equilibrium quantity, on the other hand, shall fall. And what about QD? Fall also, correct? Because you have a movement. You have a movement from point A to point B along the demand curve in that direction. Yes? Your next exam, by the way, which is next week, will have a number of problems like this. Okay, you'll have to analyze the effect of certain events on the equilibrium price and equilibrium quantity. Okay? Now we're going to come to something more interesting. And what happens when both demand and supply change? And there's a little note at the bottom here. It says here, when both the demand curve and the supply curve shift, there will be uncertainty about either the new equilibrium price or the new equilibrium quantity. In other words, you won't know what's going to happen to one of them. There'll be ambiguity about one of them. You'll be sure about one of them, either P or Q, but you'll be uncertain about the other, always. Okay? And let's think about this. So what are our possibilities? And I'm going to now go to my drawing board again. So what are our possibilities now? Our possibilities are, well, sorry, pardon. Let's say that demand rises and supply rises. That's our first possibility. Our second possibility is demand rises and supply falls. Our third possibility is demand falls and supply rises. Our fourth possibility is demand falls and supply falls. Let's analyze these intuitively first, before we actually draw some diagrams. Okay? What do you think is going to happen here with the first? Demand rising. When demand rises, that alone tends to do what to the equilibrium price? That by itself tends to do what to the equilibrium price? Think about it. When demand rises for a good, what will happen to the equilibrium price? Come on, quickly. Price will tend to fall or rise. Hey, come on, if all of us start buying gas guzzlers, what do you think is going to happen to the price of gasoline? Rise, am I correct? That's the intuition, right? The demand curve shifts to the right, and that we know causes the price to rise. Am I making sense here? So I'm not asking you to, in a sense, become intuitive again. Instead of in your mind drawing a diagram and then trying to figure it out that way, take a leap now, okay? Don't do that diagram business in your head. Just think about it intuitively. Yeah? A rise in demand tends to push up the price. Agreed? On the other hand, an increase in supply does what to the price? If Saudi Arabia starts to pump more oil out of the ground, which, by the way, they are doing, what will that do to the price of oil? Yes. So we would have, you see, so now, because of this, what do we have? We have ambiguity. Am I correct? We don't know what's going to happen to price. Is it going to rise or fall? There are two opposing forces here on price. Correct? What about the equilibrium quantity? Well, if consumers are buying more, demand's rising, and suppliers are selling more, supply is rising. Well, it stands to reason that in the end, the equilibrium market quantity should rise. Am I correct? So you have here Q star unambiguously rising. Am I making sense here? If demand's going up and supply is going up, you expect to see a rise in the quantity both bought and sold. Correct? Okay, next, let's look at this. Demand rises, supply falls. Demand rises. Now, what does that tend to do to the price? Supply falls. If there is a reduction in the supply of milk, let's say, right? Let's say that Brownsville's not getting enough milk anymore because a highway between here and Harlingen's washed out or flooded or something. What will happen to the price of milk down here? Rise. Exactly. So when there is a decrease in supply, you expect to see a rise in the price. So now we have no ambiguity about price. Price, both forces, demand and supply shifts, are causing the price to rise. So in the end, we have the price unambiguously rises. But now let's look at the equilibrium quantity. Demand's going up. So consumers are buying more. However, firms are producing less. So what is going to happen to the quantity bought and sold? You have ambiguity here. You see, the actions of the consumer would tend to drive up Q star, but the actions of the producer would tend to drive down Q star. Correct? So we now have ambiguity about Q star. Am I making sense to you here? Next. Demand falls, supply rises. A fall in demand, what will that do to P star? Yes, you see, if you and I start to buy less of something, all of us, if something just becomes less fashionable than it used to be, what is going to happen to the price of that item? You expect it to fall, am I correct? For instance, because of all this Pandora, things like that, I believe people are buying fewer CDs now than they used to. Correct? And what do you think will happen to the price of CDs? I would expect them to eventually start to fall as people buy less CDs, fewer CDs. Correct? So with the price, with demand falling, you expect price to fall. With supply rising, what happens to the price? Falls also. So the price falls, and so we have no ambiguity here. Price certainly falls. What about the quantity? Now, there is a decrease in demand, so that by itself would tend to drive down the quantity bought and sold. However, supply is going up, and that would tend to drive up the quantity sold. So now you have these opposing forces on quantity. Am I correct? So we would have ambiguity about, right? And the last case now. Demand falls, we've already worked out that causes price to fall. Supply falls. Supply falls. That means price is going to rise, tend to rise. So we would have price. So then we have ambiguity here. What about quantity? Well, consumers buying less, that would cause quantity to fall by itself. And suppliers are producing less as well, and so that too would cause quantity to fall. So there is no ambiguity about quantity, it will. Yes? Now, there is a way to look at this graphically also. And let's just pick one of these, all right? Let's say we go with number 2 here. Okay? And let's analyze number 2 graphically. Quantity, price, demand, and supply. So what do we have happening here? Demand's going up. So this would be a shift in which direction? This would be a shift of the demand curve in. So that's the new demand curve. Agreed? D prime. Now, supply is going down. So there would be a shift leftward in the supply curve, correct? But here's what we're going to do. We're going to make 2 possibilities here. One would be a very small leftward shift. In other words, supply falls, but by very little. The other possibility is supply falls by a lot. Okay? So now, what are the various possibilities here? Okay? What was our original equilibrium? This point here, let me call it point A. Right? The new equilibrium could be where? It could be either this, correct? Or, tell me? Yes? Now that doesn't quite look like a C. Let me just tidy that up. Right? Now let's look at what's happening to the price. So the original price was this, and the original quantity was this. The new price could be that, or that. In either case, the price rises. You can be sure of that, correct? But now let's look at quantity. This could be the new equilibrium quantity, or it could be this. So let's make sure we label this correctly. So this is the original Q star, and this is the original P star. But you can see, oh, I'm sorry, no, that's wrong. Oh. The original P star is this. So we can see here that the new P star could be either this or that, so we have no ambiguity about P star. P star certainly rises. And that's what we have here. We worked that out already, correct? What about Q star? You can see here that Q star could rise or fall. So there is ambiguity about Q star, right? And we have shown that here already. So you could do this graphically also, right? Point is, once again, that when both curves shift, then there will be ambiguity about either the equilibrium price or the equilibrium quantity. And before I get off this page here, could you tell me what might cause this to happen, the events that we just analyzed? The increase in demand, decrease in supply. Could you tell me from those 2 critical slides that deal with factors causing changes in demand and factors causing changes in supply, could you give me 2 possible reasons why you have an increase in demand and a decrease in supply? Somebody? What could cause an increase in demand? Anyone recall? Pardon me? springs dried up would not cause an effect on demand. That would be a supply side effect, wouldn't it?
Yeah, when summer hits.
Yes, something like that. So here we are talking about demand going up. So if this is bottled water, then we have summer hitting, right? You have a change in tastes and preferences, perhaps. You have a change in income. Maybe people's incomes rise and the good is a normal good. You remember that list of factors there? You have to refer to that, okay? So let's say that we have an increase in consumers' taste for the good. And this is something that, if the good were bottled water, this could be caused by the temperatures rising. You follow me? When temperatures rise, your taste for water rises, in a sense, doesn't it? You begin liking water more than before because you're more thirsty. So this could cause the rise in demand. And now what about the supply? The fall in supply. What could cause that to happen? Do you remember the list of factors that cause changes in supply? Now it could be that the cost of raw materials rises. If raw materials become more expensive, we expect to see a decrease in supply. Is that correct? When fertilizer prices go up, for instance, the farmer uses less fertilizer, hence supplies less wheat. Right? So events like this. So the questions that I will give you in the exam would have events. I will give you something from the list that affects demand and perhaps something from the list that affects supply. It'll be up to you to make that connection. Right? If I say something's happening, you'd have to decide, well, is that a demand side thing or a supply side thing? Is it going to cause a shift in demand or supply? That is something that you need to figure out by familiarizing yourself with the contents of those two critical slides. Okay? So that really brings us, we've discussed all this now, this brings us really to the end of this lecture. Okay? In the time that I have left, well, I don't have any time left actually, so we will stop here today. You have, I believe, a homework due, a Micon Lab homework due this midnight this Sunday, correct? And your exam next week is, remind me the day? Is it Wednesday? Wednesday?
Yes.
Oh, Wednesday is your exam.